All right, let's talk about something that happens on pretty much every corporate network, but often in the shadows, the constant chatter between your servers. We're going to dive into securing your Active Directory and making sure those conversations stay completely private.
To really get a handle on this, think of it like this. Standard, unencrypted LDAP is like sending a postcard. Seriously, anyone on the network who's looking can just read the contents. But LDPS? That's LDAP over SSL. That's like taking that same message, sticking it in a locked, armored briefcase, and then sending it. Sealed, secure, and totally private.
So let's stick with that postcard idea for a minute. You really have to understand why sending these unencrypted messages all over your internal network is such a huge risk.
By default, all this vital communication, I'm talking authenticating users, looking up permissions, all of it, it's all happening in plain text. It's flying across your network on port 389. That's kind of like shouting usernames and passwords across a crowded room. Yeah, it works, but man, it is not secure.
And this is where it really hits home. We're not even talking about some sophisticated hacker halfway across the world. What if someone already inside your network could just listen in and pluck those credentials right out of the air? With unencrypted LDAP, that's not some far-fetched scenario. It's a very real possibility.
But hey, it's not all doom and gloom because there is an incredibly elegant solution to this. It's time to bring in that armored briefcase. Let's talk about the LDAPS tunnel, which is really the hero of our story today.
So LDAPS stands for LDAPS over SSL, or, more accurately these days, TLS. What's so cool is that it doesn't change the LDAP message at all. It just wraps the entire conversation in a secure, encrypted tunnel. Nothing gets in, nothing leaks out. Our postcard is now safe and sound inside that briefcase.
And here's where you see the change. We're ditching that unsecured port 389 and switching over to the secure port 636. And just as a side note, if you're talking to the global catalog, which is basically the phone book for your entire Active Directory forest, you'll use port 3269. It's a simple change in number, but it represents a massive leap forward in security.
Now, you can't just flip a switch and get this secure tunnel. It requires a specific digital key, an SSL certificate. And for LDAPS to work, this certificate has to play by some very, very strict rules. There's no getting around them. Okay, there are 5 non-negotiable requirements here. First, the certificate's purpose, its enhanced key usage, has to be for server authentication. This basically tells everyone its job is to prove the server is who it says it is. Second, the name on the certificate has to be a perfect match for the server's full name, like dco1.yourcompany.com. Third, the server's got to have the matching private key to unlock it. Fourth, it has to use Microsoft's standard security provider. And finally, and this one's huge, it needs to be issued by a certification authority, a CA, that both your server and your clients already trust. You get even one of these wrong, and that secure tunnel, it's not happening.
All right, so you've got this perfect certificate that follows all the rules. The next big question is, where do you actually put it on your domain controller? Well, you've got a couple of choices.
So you can put it in the local computer's personal store. That's pretty standard. But the preferred spot, the smarter move, is to place it in the NTDS service's own personal store. And here's why that's so awesome. Active Directory is hard-coded to look in the NTDS store first. If it finds a valid certificate there, it'll just start using it, often without you even needing to restart the server. It's just cleaner and way more efficient.
Okay, so we know the rules and we know where the certificate needs to end up. So how do you actually get this digital key in the first place? Let's walk through the basic process.
It really boils down to 4 main steps. First, you create a formal request file right there on your domain controller. Second, you take that file and submit it to your certification authority. Third, after the CA gives you the certificate, you install it back onto that same domain controller. And finally, you might need to give the service a quick restart just to make sure it sees the new certificate and officially turns on LDAPS.
And what's really important to remember is that this fundamental workflow, request, submit, install, it's the same whether you're using your own internal Microsoft CA or a big commercial one. The specific commands might look a little different, but the core logic is exactly the same.
All right, the hard part is over. You've followed the rules, you've forged the key, you've installed it in the right place. Now comes the best part. Let's verify that you've successfully flipped that secure switch. And you can check this with a handy little built-in tool called LDP.exe. It's super simple. You tell it to connect to your server's full name, but this time you do 3 things differently. You tell it to use port 636, you check the box that says SSL, and you connect. If it connects successfully and you see all your directory info pop up, then boom, it's working, you're secure.
And that really brings us to this amazing quote from Microsoft's own documentation. It gets to the heart of why this is so great. There are no complicated config files to edit, no registry hacks. If you do the work up front to get a properly formatted certificate and put it in the right place, LDAPS just turns on. It's a beautiful, elegant system that rewards you for doing things the right way from the start.
So there you have it. You've just swapped out all those insecure network postcards for armored briefcases. You've closed a massive internal security hole, and your authentication traffic is now private. The only question left is, with that foundation now rock solid, what are you going to go out and secure next?